So, today we're going to talk about translating between words and math. And here on the screen, you can see that I have an example of a wheel that I used to use with my students when we would first start talking about translating with between words and math. And so we took the time to identify words for each operation. So we have addition, subtractions, multiplication, and division. And you can see the different words we have on screen. This is something we would brainstorm, see how much of them they could come up with, see if they really knew these words, sum, difference. I have these capitalized and I'm going to make them even bigger because these are terms that they do tend to forget. They do tend to mix up. And so when they see them in a question and it says find the sum of or find the difference of, they sometimes forget. So those are very important vocabulary words for them to be familiar with as far as the meaning of the operations. So these are all examples. As I said, we brainstorm them to begin with, and then if there are particular ones I want them to make sure they have in their wheel, then I suggest them and we add them. And then we can look at how to apply some of these. Now, I'm going to start with some simple ones. 7 more than a number. So 7 more than a number means I have a number, could be X, it's just some number. So I have a number and I want 7 more than that. So in our wheel, we can see addition is more than. I'm having more, I'm adding on. So we start with the number and then we add on 7. 7 more than a number. Some number squared actually is something like 3 times 3. That's something that they might remember from the past. We don't really have squared in the chart. I'm going to unsuperscript that, but we probably could put that here because squared does mean to multiply a number times itself. So I'm going to change that and add squared. Okay. We could also add other powers. We could add cubed in there or to the power of. The sum of a number and 8. I'm going to go here. The sum of, so sum is add a number, we don't know what it is, and 8. Now, these are all with variables. We can do this, the sum of 5 and 8, with just numbers, and they still need to understand that the sum of 5 and 8 is 5 plus 8. The quotient of a number and 20 means we've got a number divided by 20, and I'm going to use the fraction bar there. Quotient of a number. So since the number comes first in this statement, we have to put it first in the expression, the quotient of a number and 20. Down here, we did not put it, 7 came first, but we did not put it first because we are supposed to do 7 more than a number. So we start with the number and add on 7. Sometimes the order is not important. Sometimes the order is. So I do tell students, even though something like this, x plus 8, could be 8 plus x, and it technically is the same thing because the commutative property says we can add in any order and we get the same answer, I ask them to stick with what is meant by the actual statement. So in adding here, it says a number and 8, so I'm going to put it in that order. Here, some number more than 12. So I want something more than 12. In this case, I would start with 12 and more than is add. So I'm going to add a number more than 12. So you can see how this one, some number more than 12 and 7 more than a number, we start with something different because we're adding on to a number or we're adding on to 12. 15 less than a number, the first one. This is one that students do get mixed up on. And in this case, the order does matter because it's subtracting. We can't take 15 minus 7, flip it around to 7 minus 15 and get the same thing. So we want 15 less than a number. So we are starting with a number and we want 15 less than that. We want to take 15 away. So that's one to be on the lookout for when you're working with students. The less than, more than ones, they tend to mix up. So it's important to read very carefully, 15 less than a number. And sometimes it's a great idea to go ahead and put a number in there for number, 15 less than 17. Like if I said, okay, 15 less than 17, How would you find 15 less than 17? 17 minus 15. Okay, so if they use a real number in here, it does help them to understand how that translates to the algebraic expression. So I'm going to get rid of that. 25 decreased by a number. So we have 25, and 25 is the number being decreased by something. Now, if we said 25 decreased by 3, okay, you have 25, you're making it smaller, decreasing it by 3, you would end up with 22. So you would have to start with the 25 and take away the 3. Down here, some number less than 35. So a number less than 35. Some number that is, we're going to be not is less than, but some number less than. So let's pretend we wanted it to be 10 less than 35. To find 10 less than 35, we would do 35 minus 10, or in this case, the number. The product of 13 and a number, that one's pretty simple. Product means multiply, so multiply 13 times a number. And I don't like to use x as multiplication when we have these expressions, because technically technically x is a variable in an algebraic expression. So I'm going to make the dot for multiplication and just use x there. So we have the product, 13 times a number. Some number less than 18. So we want a number less. We want to take away from 18, so 18 minus the number. And a number increased by 2. That means I'm going to start with a number, I'm going to increase it or add on 2. Okay, then we're going to go from expression to phrase. So we could say simply 28 divided by x. Or we could say x groups, or 28 divided into x groups. 24 minus x, we could simply say 24 minus x. We could say x subtracted from 24. We could say decrease 24 by x. Or a number less than 24. Because we're going to take away some number, so it's going to be a number like 7 less than 24. X plus 9, we could just say x plus 9. We could say 9 added to x. We have added it on to x. We could say increase x by 9. 5y means multiply, so this can be 5 times y. It could be the product of 5 and y. It could be 5 groups of y. Okay. And then x divided by 8, we can again say x divided by 8. Now the x comes first, x divided by 8. We don't want to say 8 divided by x. That's not the same thing. So we need to make sure the order is correct. Order will always matter with subtraction and division. You can't get the same answer with subtraction and division if the numbers are in the reverse order, if they're flipped around. Adding and multiplying, you can technically get the same answer, but we still want to keep them thinking about what is actually happening in the statement. 25 is decreased by a number. A number is increased by 2, that kind of thing. Okay, that is about it for the practice. I'm going to skip this last x minus 12 because we're running out of space. Let me know if you have questions.